Chapter 5, Data Communication Fundamentals. So what is analog and digital data communication? Or what is communication? It is the way in which the electromagnetic signals are encoded to convey data that determines the efficiency and reliability of the transmission. The way you encode will affect the efficiency of your transmission. So we have data. We convert it into signal. Then we send it on the media cable using transmission. Okay, by the method of signaling. Let me simplify it for you. I have some information. Let's say I have a piece of paper, or I have some, I want to send it. How I will send it? I will convert it into an email, I will convert it into an image file, or scan it, attach it to an email, and send it. Same thing, you have data. You cannot just throw the data to the receiver or send the data by itself. You have to convert it into a signal. When you convert it into a signal, you send it, you do encode it on the transmission line, and then you have to follow some protocol for signaling. So this is the meaning of this. So data is entities that convey meaning or information. In some other books, information is that has meaning. Data has no meaning. But here, you have to follow. Data is entities that convey meaning or information. Not necessarily organized. If they are organized to give information, then they are called information. So data could be raw data. But here, as per the slide, entities that give information, okay, useful information. Signal is electric or electromagnetic representation of a data. Okay, you represent your data by electromagnetic signal. So signal is going fast if it is 1, or low, or going slow if it is 0, and then changing the values. Transmission is the communication of data across a computer network by the propagation and processing of signal. Propagation and traveling. We like to use our own terminologies for telecommunication. So instead of saying traveling or transmitted, we say propagate. For electromagnetic signal, it's propagating. Okay. Signaling is the physical propagation of the signal along a communication medium. How it is traveling on the medium itself. Signal, medium. I put the signal on the transmission line. It is signaling that control its traveling in the medium, or propagation in the medium. So please try to understand the concept. So we have analog data. It's continuous values on some intervals. Like example is voice, video. Human voice is analog. If you know someone talks digital, let me know, please. Maybe robots, huh? But it's not a human. So. Then we have data collected by sensors also, such as temperature, analog temperatures, and pressure sensors. Digital data are discrete values, such as binary data, integer numbers, like 0, 1, 2, 3. This is integer. Signals are used to encode and transmit data. So we knew about the analog data. Then what is the analog signal? The analog signal is continuously varying electromagnetic wave that may be transmitted over both guided or unguided media, wired or unwired, guided or unguided. I told you telecom people, they like to give different names. We called this before wired. Here they call it guided. Okay. Digital signal, sequence of voltage pulses. Generally cheaper than analog. Analog used to be analog equipments. Some people, they have a hobby. Analog equipments, they were very expensive. Used to be very expensive. And you go to certain shops to buy these equipments, very expensive. And you have to buy compatible devices. The digital ones are cheaper and they are less susceptible to noise interference because they are digital, but suffer more from attenuation than analog signals. Cannot be used on optical fiber or wireless media. Wireless media is analog signaling. Fiber is analog. Okay, don't forget that.
Fiber?
Yes.
Fiber with cable, something.
Yeah. Fiber optic, yeah. I'm talking about when I say fiber, fiber optic, media, cable. Yeah, we'll talk about it more, inshallah, when we study fiber. Yeah, English, please, yeah.
Digital signal counts guided, right? Guided or unguided?
This is the media. I'm talking about the media, the cable. Guided is media.
Okay.
Wired. Guided
Unguided
and
is
wired. Unguided, wireless.
And the digital count as which one or both?
Digital, we have digital data and digital signal. Okay. Here we have examples of signaling. If I have analog and digital signaling of analog and digital data. Look at the example here. So here we have analog data, such as voice or sound waves. It is converted into analog signal by using the phone. This is normal phone, analog phone. Or if I have digital data like binary voltage pulses, it is converted into analog using the modem. And the modem is what? Modem stands for what? Modulator, demodulator. Very good. So at the transmitter side, it will be converted from digital data into digital signal. Sorry, where are we? From the digital data into analog signal at the modulator side, at the transmitter. When it arrives at the receiver, that's another case. Now, if I have digital signal, what is digital signal? It represents data with sequence of voltage pulses. We already know that. Okay. So if I have analog signal, I can represent it with digital signal, like pulses. Okay. If I have digital data, then it is easy to convert it into digital signal by using the digital transceiver. Analog signal into digital signal, we use a codec. Codec stands for what? Coder, decoder. Transceiver, transmitter, receiver. That's how they name them. Okay, so you have to know this, please. So again, here they are repeating it. Analog data into analog signal. A transmitter technologies use modulation techniques that enable sound or video waveforms to be conveyed as electromagnetic waveform over wires or airwaves. or wirelessly. Digital data over analog signal such as modem, which stands for modulator demodulator, covers binary voltages pulses, converts binary voltage pulses by modulating a carrier frequency, demodulates at the receiver side to recover the original data at the other end or at the receiver. Codec, which stands for coder decoder, takes an analog signal and approximates that signal by a bit stream. At the other end of the line, the bit stream is used to reconstruct the signal. Now, these are the combination benefits. Why we are doing this? What is the benefit of each one? So for the digital data, digital signal, the equipment for encoding digital data into digital signal is less complex and less expensive than digital to analog equipment. Always, and if you are moving to digital, cheaper, less expensive, more efficient. Analog data and digital signal. Conversion of analog data to digital form permits the use of modem, digital transmission, and switching equipment. Digital data and analog signal. Some transmission media, such as optical, and some people say, why we are still using analog and why we are, because fiber optic uses analog. Fiber optic is very fast, but we are making the use of the speed of light or electron. What is the approximate speed of light or electron? Almost 300,000 kilometers per second. Very good. And the speed of light, the electron can rotate around the Earth 8 times plus per 1 second. Per 1 second can rotate 8 times around the globe. Okay, so that's how fast it is. Okay, and analog data and analog signal. This is the legacy technology. That's what was there before. So analog data are easily converted to analog signal.
Doctor, I have a question.
Yes.
For example, analog data to digital signal. Can we give an example as a microphone?
Yeah. Analog data to analog signal, yes.
Analog data to digital signal.
If you are using digital mic, yeah.
And
Thank you. So here, transmission choices, we have analog transmission. What are the characteristics? Again, we are repeating. Only transmits analog signals without regard for data content. Does not recognize what's inside the wire. You cannot deal with it. You understand? And signal is traveling, analog signal, خلاص. You cannot control, you cannot protect the security, you cannot compress. Attenuation overcome with amplifier. We told you this last time. For analog we use amplifier. For digital we use repeater. Very good. Very good. Digital transmission transmits analog or digital signals. Analog transmission will transmit only analog. Don't forget that. Okay. Digital can have analog or digital data signal. Uses repeaters rather than amplifiers. Switching equipment evaluate and regenerate signal in the repeater. Advantages of digital transmission. Again, we are repeating some of the information. Digital is cost effective. It can be handled on large scale, utilized for large scale. Data integrity, effect of noise and other impairments is reduced. Capacity utilization, high capacity is more easily and cheaply achieved with time division rather than frequency division. Okay. So we can do capacity utilization. We will talk about this when we show you how we use time division and frequency division multiplexing. I can transmit multiple signals together. Security and privacy. With digital, we can do encryption. Can we do it with analog? Human voice traveling, how you can encrypt? If it's analog only, you cannot. We have integration. That's one of the very important advantages of digital is you can integrate CCTV, video, internet, IP telephony using the same transmission. You can send everything on the same media. Okay. However, some people still they don't do that. I worked before in oil and gas company, and we were in industrial area. There, we had one network for internet, but they insisted on having a network for the oil wells, the oil tanks. They refused to use the same network of the internet and the telephone. They had their own network. Even also in military, I think, military bases, they have the same. They don't like to use the normal telephone that's used for the internet and data.
They have something.
Because for security, for other things, so many things. Okay? And redundancy.
They have local area.
Yeah. They have their own network. Integration, all signals. Okay, that's the integration. Data encoding technique, analog or digital data must be converted into a signal for purposes of transmission. The mapping from binary digits to signal elements is the encoding scheme for transmission. This is the definition. The basis for analog encoding is continuous constant frequency signal known as the carrier signal. Modulation is the conversion of digital signals to analog form. Demodulation is the opposite. So this is example, modulation of analog signal for digital data. Here I have digital data 0011. What's happening for the modulation? If it's ASK, amplitude shift key, when it is 0, you see here the value or the peak value is 0. When it is 1, I have higher amplitude. When it is 0, lower amplitude. So this is called amplitude shift key. The other one is binary frequency shift key or FSK. And some people call it just FSK. In the exam, most of the time they will put FSK, which is frequency shift key. Here, what is changing? If it is 0, only the frequency is low. If it is 1, the frequency is high. 0, low, frequency, surah. Okay. The third one is phase shift key. Here the phase is changing, the angle is changing. See the angle? When it is 0, it is going upward. If it is 1, it is going the opposite. Okay. Modem is one of the most widely used pieces of communication gear. We already talked about it. Modulates an analog carrier wave to encode digital information. And on the receiver, it will do the opposite. Some examples for the use of modems is direct broadcast satellite, Wi-Fi, mobile phones use modem to communicate. We have 3 types of popular types of modems, which are voice grade, cable modem, and ADSL modem. Cable modems, this is an example here. It is provided to you by the ISP will provide you with fiber feeder, and then when it arrives, you need to plug in a cable modem to be able to connect it to the modem coming from the ISP. The other one is ADSL modem. This is the one used for by the ISP when you are subscribing to internet. They call it digital subscriber line. I think most of you have this nowadays. Yeah. It's combining different services together. This is the fiber to the home. With this fiber to the home will provide you with the fastest internet connection rate or bandwidth. Okay. Here you have an optical splitter, and then it's dividing the fiber optic service to each home in the compound or in the city or in the town. This provides you with the highest bandwidth, but on a cost also. Examples of digital signal encoding. Here I have digital data. I want to convert it into encode it on digital signal. The first method is called non-return to zero, NRZ. Please pay attention. If it is 0, I have high voltage. 0, high voltage. 1, straight away, low voltage. 1, low voltage. 0, high voltage. 1, low voltage. It's called NRZ, non-return to zero. The NRZ inverter, whenever there is a 1, it will toggle. If it's low, it will go high. If it's high, it will go low. It's called inverter, toggling. It's like push button switch. The third method is Manchester. Manchester, it's changing its value in the middle of the interval. Yani this is the interval, right? This is the period. The changes is happening in the middle. If I am going 0, then it is coming high-low in the middle. 0, high, you see, 0, high, low, going down. 1, it will go up in the middle of the interval. 1 again, it will go up. 0, it will go down. That is Manchester. Differential Manchester, like in math, differential is the opposite. Okay, you know the differentiation. I will give you example once we finish. Inshallah, there is an exercise. Solve the exercise for each one of these. Okay. The second one is called non-return to zero inverter. When it is 0, no change. See here, 0, low voltage. Okay. When it hits 1, when it is 1, it will change its value. So from low to high. Again, I have 1, it will change its value.
But it said
No.
here in 1.
No. Here 1,
Yeah.
another 1, then I'd go down. Because this is another one, not the same one.
So
Another bit.
if there was instead of 1,
0, it will not change. Yeah, it will not change. I will show you one example at the end. It is there in the activity, but we'll do it together. Okay? Analog encoding of analog information. Voice-generated sound wave can be represented by an electromagnetic signal with the same frequency components and transmitted on a voice-grade telephone line. This is the old telephony system. Modulation can produce a new analog signal that conveys the same information but occupies a different frequency band. Higher frequency may be needed for effective transmission. Analog to analog modulation permits frequency division multiplexing. Here it is. Here I have the carrier signal. The carrier is the one which will carry my signal. Okay? When you talk, there is frequency, but it does not have energy to travel by itself. So you have to convert that signal to encode it on a stronger signal. We call it the carrier signal. Okay? So this is my carrier signal here on top. And then you can use different modulation techniques. You can do the amplitude modulation. With the amplitude, you are changing the amplitude, the peak, and the amplitude value. With the frequency again, frequency modulation, we are using the frequency. So we are changing the frequency. When it's going up, the frequency is increasing. When it's going down, the frequency is decreasing. Or we can do phase modulation. Here, the phase is changing. Yeah. One technology is synchronous transmission. In the synchronous transmission, blocks of bits transmitted in a steady stream without start and stop codes. Okay? Because they are synchronous. Synchronous meaning that they are both synchronized with each other. I don't need to tell you I will start now communicating because we are already synchronized. Okay, no need to tell you of a start bit and end bit. We are synchronized. Okay. The clocks of transmission and receiver, they should be synchronized, their speeds or clocks. It provides a separate clock line between transmitter and receiver, works well over short distances. Embed the clocking information in the data signal to keep synchronized. Each block begins with a preamble bit button and generally ends with a post-amble bit button. Instead of the start bit and end bit, we are using preamble and post-amble bit. That's the name of the bit. Like we say, parity bit, This one is called preamble and postamble. The data plus preamble and postamble and control information is called a frame. So the whole data with the control and the postamble and preamble is called the frame. And we know frame is in which layer of the TCP/IP? No, we have application, transmission, data access. And frame is in the layer 2 of the OSI model. Okay. And most of the WAN is happening, by the way, in the first 2 layers. The one, yeah, encoding and these things is happening in the first 2 layers. The routing is happening in the network layer. It involves the use of a data link control procedure which automatically detects transmission error and causes a frame and error to be retransmitted. The data link will detect if a frame came with error, it will ask the sender to retransmit that data. All right? The error control process, because all transmission media have potential for errors, all data link layer protocols must provide a method for controlling errors. We have 2 components for error control. Either we do, first is error detection. So redundancy introduced so that the occurrence of an error will be detected. You have to detect if there is an error. And how to correct. The method to correct is by informing the sender or the transmitter to resend. I will not open the frame and start repairing the frame, just because we are very quick here. Just ask for resend. Okay. Parity checks. Here, one method of error detection, you add a bit called parity. Yani you want to make sure that if your frame is odd, yani ending with 1, we will finish, inshallah. If it's ending with 1, it's odd number or even number? Odd number. So you want to make sure it's even, so you add a bit. Okay? That's just an example. So we call this parity check. So if I tell the receiver, I am sending you an odd, okay, and he receives an even, then this means there is an error. So it's very basic method. Okay. Imagine I lost 2 bits. So it's still even, yani, or it's still odd. But the receiver will not know. He will think that maybe you forgot, you lost only 1 bit, or 1 bit is damaged. 10 bits could be damaged, and the receiver will think only 1 bit is damaged. So it's not really a very efficient way. Okay. So it's good for detecting signal bit errors only. Noise impulses are often long enough to destroy more than 1 bit. Okay. So it's not the ability of parity checking to detect error is dependent on the total number of bits corrupted by noise impulses and the parity convention that is used. This is here a summary of what we have studied in this chapter with the devices that are used. So codec for analog to digital, modem digital to analog, and this is example of the device names that we just talked about. Okay. And the encoding scheme. So for digital to digital, we use Manchester, differential Manchester, NRZL or NRZI. Okay. This is the summary. Now I'll stop here.